What's up, everybody? Welcome to the Crypt. In this video, I'm going to be talking about proof of weak hands 3D, and more specifically, I'm going to be going through the code and reviewing it. And before I begin, there's a few things I want to talk about. If you really don't care and all you want to do is get into the code, skip ahead into the video and we'll go through it. Try not to let the hairline get to you, man. I know I'm losing my hair, man. I'm getting kind of old, but I don't think any big YouTuber is going to be reviewing this code. Like Ivan on Tech wouldn't go through and review this code. And I understand why. It's because they really don't want to dirty their hands into something like this. I mean, after BitConnect and Davercoin and all these other lending platforms and their exit scams, they don't want to get involved in something like this in order to muddy their name. I'm a brand new YouTuber. You know, this is my first video on YouTube, and I think that this is going to really show people that this is actually a strong program. I am invested in P3D, don't get me wrong, so I'll put that out there. And this is not an investment advice. All I'm doing for you guys is going through the code and showing you what's possible, what's not. Is what they have on their website actually legit? Are they actually, are they actually doing what they say they're doing? You go on here and they make some pretty serious claims here, and like decentralized exchange. They make a lot of other claims down in here. Open source, it is open source. Withdraw anytime. Can you really withdraw anytime? These are the kind of questions that I want to answer for you guys. So what I'm going to do is I'm going to go through the code and try to point out some of the things in the code that people really care about. You really care. Am I actually investing in something that does what it says it does? Okay. I have to admit, after going through the code myself, literally everything on this site I believe is accurate. Okay. And it's not necessarily a belief, it's in the code. It's written in the code. And I'm going to show you guys that here right now. Here is the contract source. We're at proof of weak hands 3D. This is in fact the proof of weak hands 3D address. So this is the contract source. I'm going to be reading it straight from Etherscan. So this is what is on the blockchain. Okay. And one thing you have to know about the Ethereum blockchain is that once code is on the blockchain, it cannot be altered. Okay, so that's an extremely important point. And also I want to point out that the current Ether balance inside of this contract is 13,156 Ether. What they have written on there, well, I can't get right now the exchange down. So recently they had a sell off, and there's a lot of people that kind of try to come in to crash the site, and it looks like an exit scam, guys. It really does, but there's no way you can exit scam. This is not the only exchange. In fact, since this is on the Ethereum blockchain, anybody can write an interface to exchange with proof of weak hands 3D. Anybody can. So it is a decentralized exchange. They just provided the front end. That's all they're doing, is providing the front end, so that way nobody else has to write it. That's all that they're doing. So yeah, right now I'm getting fetch in database, but there is a backup site, and if you're in the Discord, this thing is getting spammed all over the place right now. So I don't have MetaMask open, so it's still loading. Anyway, let's get right down to it. Okay, Pragma Solidity, and then they have this version code. Basically, this just tells the compiler to make sure to interpret the code using this version of Solidity. That's all that means. Because if the version changes, then some of the nuances in the code also change, and you want to make sure that the compiler knows exactly what is being compiled here. Okay, so a /* for you non-programmers basically means it's the beginning of a comment block. That means you can put anything you want in here, and everything's a comment up until the next */. And so whatever's in here does not get executed. It's ignored by the compiler. It's just for information for us, so they can tell us quickly what the code's actually doing. But it's what the code is doing that is important. Okay, we're at contract hourglass. Well, this is just defining hourglass. Okay, let's move on down. We have a modifier. So what the modifier is doing is it's tacked on to functions to only allow functions to execute. Well, it depends on what the code says, but typically, these are only allowing functions to execute under certain conditions. If they don't execute, then the transaction fails. You still pay the gas though. So modifier, only bag holders. Require, so this require means that basically we have to go look at what my tokens means. Okay, but it has to be greater than or equal to 0 in order for the function to execute. So when we see this, I'll reiterate that again. Let's go see what my tokens means. So here it is, function my tokens on line 497. Okay, retrieve the tokens of the owner of the caller. Now, I'm not going to skip over anything. Even the most mundane function I'm going to be reviewing here, because this thing needs to be tore apart in order to prove that this thing is legit, okay, or not legit. We need to find those little things, those little kinks in the code to determine whether or not we are actually if they're doing what they say they're doing. So function my tokens, this is public. That means it can be called you can actually send a transaction to the Ethereum blockchain to actually get this information. View means that it's a read-only function. It's not allowed to modify any of the data. It's only going to be able to read data. And it returns a specific type, uint256. Basically what this means is that it's a positive integer. It can't be a decimal, and it's going to have a capacity of 256 bits. That's all that means. So positive integer, that's actually really the only thing that's very important here. It can't be negative, so it can't be like -3. It can't be, you know, anything negative. It has to be 0 or higher. Okay, here we have address, and that's just a variable type. And we're defining basically the customer address. So we're taking the sender, so whoever sent the transaction, we're just copying it into here, and then we're just returning balance of customer address. So all this function is doing is just taking the sender. So when I go to a transaction, for example, the sender is the address that the transaction is coming from. Okay, so that's all that means. And it's going to return the balance of. Now, this is another function, so we got to go find that function. Now, one thing you'll see is that as I go through the code, we're going to be bouncing all over the place because we got to follow the code and we got to understand what it's doing. So right now, we're calling another function, balance of. So let's go there. It accepts an address. So we're passing an address to this function, and it's going to be labeled this, return token balance ledger, and it's going to be of the customer address. So it's going to take the token balance ledger and just return it. That's all it does. But we still need to define what token balance ledger is. So let's find that. Here it is. And it is simply a mapping of an address to a uint256. Remember, uint is a positive integer. And basically what we're able to do is we're able to store information about an address. And that information is simply going to be a uint. So what I've concluded here, based on what I've read, is that only bag holders, literally my tokens isn't doing anything special. It's literally just getting the number of tokens that is at the address that sent the transaction. That's all this is doing. And then we have an underscore, which basically means go ahead and execute the function. So here we are, we're at the Solidity documents, and this is going to explain what the underscore actually does. And the Solidity documentation this is how you actually program a smart contract on the Ethereum blockchain, and it explains exactly what the underscore does. And it says that in the definition of a modifier, this means that if the owner calls this function, the function is executed, and otherwise an exception is thrown. So basically, if it's not there, then your function doesn't execute, and the transaction just goes out the window. Down here, we're on line 51, modifier only strong hands. So we're only going to execute apparently only with people with profits. So this is requiring that my dividends, and it's passing a true value, and that's actually we'll get to what this is actually doing here in a second, but it has to be greater than 0. So now we have to see what my dividends is. Here we go, function my dividends on line 512. This is accepting a bool. That's why we are passing true to it. We could also pass false, and it wants to know if you want to include the referral bonus in the dividends. So the fact that we're passing true means that yes, we are probably going to include the referral bonus, but it depends on what the code says, guys. It depends on what comes out. It is a public function, can be called on blockchain. View, it is a read-only function. It's not allowed to modify any data, and it returns a positive integer. Address, so we once again copy the address in here, and then we do then we're actually testing something. We're basically testing whether or not this is true or not, okay? And the question mark says, like, are you true? Hey, are you true? If you're true, then execute this block of code. If not, then execute this block of code. And so the fact that the include referral bonus would be true in this case, we would provide a dividends of, which is yet another function we got to go look up, of the customer address. Remember, that's the sender of the transaction plus the referral balance. And if not, then we just don't provide the referral balance. So right here is referral balance. Once again, we have to look up what this also means. Okay, so let's do that real quick, and then we'll go look at the dividends of function to see what it's doing. Here we go. Once again, it is a mapping of an address to a uint256, to a positive integer. And basically, we're just trying to store information about that address. Or trying to look up information about that address because it's a view function, right? It is internal. I never explained what internal meant. Basically, it means that only the hourglass, the contract, remember that line at the top, only that is able to access this information. Nothing else is allowed to access it. And so it's just another storage of information. Okay, so we're able to define what referral balance is. We're just taking the referral balance, that's whatever was stored, into referral balance at that customer address. And nothing's been stored there yet. We haven't gotten to any code that actually stores data there, but we will get there, and we'll see exactly what kind of information they're storing there. It's pretty self-explanatory given the name, but it's all depends on what the code does, and it could possibly be that they're trying to do some backhanded stuff. We'll take a look at it. All right, we need to define the dividends of. Here we go. Here's the function dividends of. It's accepting a customer address. View, that means it's read only. It's not able to modify data. Public, you can actually send a transaction to here in order to get something back on the Ethereum blockchain. Returns a positive integer. Okay, so we got some math going on here. All right, so profit share times the token balance ledger at the customer address. So we also need to figure out what this is, which we're gonna see how that's set later on. Token balance ledger, we gotta know what that is, and also payouts too, we gotta know that, and also magnitude. A lot of stuff to look up here, people. A lot of stuff to look up. So we need to figure out what profit per share is, and it looks like what they're doing is they're actually denoting a public variable, something that's accessible by all the functions, with an underscore that's trailing the identifier. Okay, so uint 256 profit per share, that means that we're able to store a positive integer into profit per share. That's all that means. Okay, and payouts too, here's that. So it's just a mapping. We're able to store information about an address, and we just want to take an integer, not necessarily a positive integer, and store it. We want to store information about an address. Okay, I guess it actually makes sense to go ahead and kind of read through some of these other ones just to kind of understand that these are actually public and maybe get an idea of what they do. Okay, so we have token balance ledger. We looked at that. Oh no, that's one we needed to actually look up, right? Referral balance. We have the payouts too. Okay, just a mapping to an int and an internal ambassador accumulation quota. So, okay, so the word ambassador right there, that can definitely be something interesting. It looks like we're actually going to be giving special permissions to certain people. That is, of course, a red flag. I shouldn't say it is a red flag. It is a potential red flag. It all depends, once again, on how the code is giving these people access. I mean, we could actually prevent people from being able to do stuff. So it can go either way. We'll take a look at what all this means. All right, so we also have a token supply. So token supply is stored publicly. All the functions can access it. And we're mapping a byte, 32 bytes to a bool. We can store information depending on what we want to put in here to a bool. And this is administrator. So it sounds like it's going to be another group of people that have some permissions. And of course they provide some, this is, by the way, another comment. When you have a // that means that it's only one line worth of comment. What the compiler does is it just ignores that line and goes to the next one. But they tell us that the administrator list, see above, on what they can do. So we'll go up here and take a look at it. All right, so they have this whole thing about what administrators can and can't do. But it's just text. We have to look at the code to make sure that that's what's happening. All right, heading back down in here. We didn't define what magnitude meant. We still got to define what that is. Magnitude is simply it's a constant, meaning that it can never be changed. It will always be equal to 2 raised to the 64th power. That's what the double star means. It's just raised to 64. So also there's a couple of there's some information right here that talks about some of the information configurables. Basically they realize that people are going to make clones of this, and they say, okay, if you want to make a clone, here are the things you can change straight up. I think it's worthwhile to go through this. String public name. So basically it's not a constant. It can be modified. Proof of weak hands 3D. String public symbol P3D. Okay, it's just it can be modified as well. The question remains, are they modified? Uint constant. So decimals, this is also just a constant. Looks like we just got a bunch of constants here. So decimals is 18, dividend fee is 10, token price initial is 0.000000. There's 6 zeros there, by the way. 1 ether. So, but wait. Isn't this a positive integer? How are we able to store a decimal into this? Well, it's not actually happening that way. This is trailed with ether. And what that means is multiply whatever this value is by 10 to the 18th. The way is the smallest denomination of ether. So we're basically just multiplying this by 10 to the 18th. So we're blowing it up. It is an integer. You take this, multiply by 10 to the 18th, you get an integer. So it's stored in there. So nothing's groundbreaking here, guys. Uint 256, okay, token price incremental is 7 zeros followed by a 1 ether. So what this is telling me is that the initial token price will be let's take a look at some more of these variables here. We have a staking requirement of 100. Now on their website, they state that you can stake 5 of your own tokens to create the first. So they're actually saying that the stake is 5 Ethereum. Now, but the thing is that the default here is 100. So that's kind of raising an eyebrow. Is it really 5 or do you need 100? It has to. So what has to happen in the code is we have to find the ability. We have to find somewhere where they're actually able to change this value. And who's able to do it is also important. Now, the comments state that administrators are only the ones that have this capability. We'll have to take a look at that. We'll get to that when we get to the code. Okay, mapping address, we got the ambassadors. So we're just taking an address. So we're associating an address to an ambassador, and then we're determining whether or not that address is an ambassador based on what I see here. Now, of course, that remains to be seen in the code. UINT constant. So ambassador max purchase, this cannot be changed, is 1 ether. So the ambassador max purchase variable is set to 1 ether and always will be 1 ether, and the ambassador quota is equal to 20 ether and will always be 20 ether. So we'll have to see what that means in the code later on. And I'm gonna go through the math of how this works in other videos. Right now, I just want to go through the code and point out some of the stuff that I see in here, so that way we can get an idea of the legitimacy of this project. What we have here is the profit share, right? Remember, that was just the storage of value, and we still need to see exactly what's stored in here. But based on the description of the variable, it's literally just how much Ethereum you get for every 1 P3D you have. That's pretty much what that seems like to me. We're multiplying it by the token ledger balance of whatever you have. So now we have a full on how much is your holdings worth. Whoever you have, how much are your holdings worth? And we're going to subtract any payouts too from the customer address. So if you paid out, then you obviously don't get your ether. We divide off the magnitude, so we're just scaling it down, and then we have to understand exactly what that means also later on. Well, we'll talk, like I said, we'll talk about the math behind proof of weak hands 3D in the later video. Right now, this doesn't seem like it's doing anything special. It's just doing some math in order to actually return the dividends of something. And there's no other function calls in here, so this is the end of the line. We're at the top of the stack. Now we start popping off the top. We go back to my dividends, and we're returning we're returning the dividends, basically, is what I can tell from the math. And we need to determine what how the variables are set, of course. And that leads us right back to the modifier for only strong hands. And it's requiring that basically you have to have dividends in order for a particular function to execute. All right, so, and then it says, okay, execute. Now, if require, remember guys, now what this require thing means is that if whatever is inside of this evaluates to false, then that's the end of the transaction. Nothing else gets executed. Nothing else gets modified. Here we are finally in the code that talks about the administrators and what they can do. Now, this is obviously just a comment, so it doesn't mean anything. It depends on what it says in the code. Administrators can change the name of a contract, change the name of the token, change the proof of stake difficulty, how many tokens it costs to hold a masternode. So there we go, in case it gets crazy high later. Okay, they cannot take funds, disable withdrawals, kill the contract, change the price of the token. Okay, so that's pretty important. Now, obviously, this is just words. It all depends on what the code says. I'm going to reiterate that a lot, guys. Don't ever trust the comment. Don't ever trust just the comments. You got to look at the code and see and make sure that's what the code is actually doing. Now, I'm going to have to slap the developers on the hand for this one, though, because there's one thing that the code does not mention that administrators can do. And it's not listed here in this text. So shame on you, devs. And we're going to talk about that here in a second. First of all, let's talk about what this modifier is. It's only administrators. So only administrators have the ability to execute a particular function that we'll see later on. The address, it takes the customer address and it's basically doing a hash of that address. And then we're actually pulling out some information about that hash, and it's requiring that this is set to true. If I don't know how to pronounce this, to be honest, but KEKAC 256, if the KEKAC 256 hash of the address does not have its administrator flag set to true, end of function. You don't get to transact, or you don't get the transaction to go all the way through. Otherwise, you can go ahead and execute the function. Now, the important thing is, let's see what functions are affected by only administrator. So let's figure that out here. Here we go. function. This now all I'm doing is just doing a search, and every single time I come up to it, we're going to see what function it is. So function, disable initial stage. It's a public function, so if you're administrator, you can execute this function. And it sets this flag, only ambassadors equal to false. So they have the ability to set this to false. Nobody else has that capability. So here, this right here is why the devs get a slap on the hand, because they don't mention this. In case one of us dies, we need to replace ourselves. Set administrator. They're basically, okay, so this is only administrator, right? It's a public function, and basically it allows an administrator to assign another administrator. Okay, so once you become an administrator, you can assign another administrator. It's not that big. It's not that big of a deal if what they say about what administrators can do is true. But I mean, it wasn't mentioned, so it's kind of like, come on, guys, full documentation here, full documentation. All right, so nothing to be alarmed here, guys. They're just saying that that administrators are allowed to set new administrators. So here's another only administrator function. Set staking requirement, so amount of tokens. And so basically an administrator is allowed to change the number of tokens that is required in order to hold a staking position. So in order to be a master node, all right, so I'm going to go ahead and assume that this was set to something else later on. And in fact, we can go to this tab right here to read the smart contract and see what this is currently set to. All right, here we go. Staking requirement. This is set to a really, really large number. How is this only 5? Don't I need 5 trillion? No, that's not what you need. This is actually 5 to the 18. So remember, guys, when we're talking about uints, positive integers, we're talking about the smallest denomination, okay? So there's a lot of denominations, so let's count this up. If there are 18 zeros, then it will be 5. 1, 2, 3, 17, 18. There are 18 zeros trailing this, and staking requirement is set to 5. So I would say yes, they are absolutely correct in stating that 5 is the current staking requirement for proof of weak hands 3D. Okay, so the administrators get that functionality. So if you ever become an administrator, you can set this. So function set name. Only administrators have this capability. They're able to change the name of the token. Essentially, is all they're able to do. We looked at that earlier. We looked at name being set to like proof of weak hands 3D. That's it. Only administrators. We're able to set the token symbol. So P3D is the current token symbol. They're able to change that. Okay. And is there anywhere else where we have only administrators? Nope. So only administrators can disable the initial stage. They can set new administrators. They can set staking requirements, and they can set the name of the token and also change the symbol. So that's the only capabilities that administrators have. That seems rather legit to me. All these things, it doesn't give them the capability to, like they said, they cannot kill the contract. They cannot take any funds. They cannot disable any withdrawals or change the price of the tokens. They can't change these things. Okay, they're only giving us a limited amount because only so many functions have this modifier. Okay, moving on, since we have identified the capabilities of administrator, let's move on to the next modifier of anti-early whale. Okay, this ensures that the first tokens in the contract will be equally distributed, meaning no divine dump will ever be possible. And I think it's very important to talk about the early stages of proof of weak hands 3D, because this is really where the ambassadors have power. There's really no other power that the ambassadors have from what I can tell in the code. And I'll explain that as we go through. Anti-early whale accepts the amount of Ethereum as a positive integer. Address, we're just copying it in. We're just copying the address into the customer address so we can use that identifier instead. Okay. So if only ambassadors and if this value is true, then this is executed. Remember that administrators have the ability to disable only ambassadors. I didn't see anywhere where only ambassadors get set to true, except for in the initial stage of the contract. So we need to understand what total Ethereum balance means. So let's go ahead and take a look at that. Function total Ethereum balance is a public function. It's read only. It returns a positive integer and it returns the balance of the contract, which what we're looking at right now is 13,156. All right, so that's pretty much what would be returned from this function. Actually, it would be in way, so that'd be a really large number. You got to understand, guys, we're talking about really large numbers, but they're divided by 13,156. a certain amount in order to keep the number of ether on a readable, human readable level. And that's it. That's all it does is return that. So, all right, let's move on up. If you take the total current Ethereum balance and you subtract off the amount of Ethereum to be bought by whoever's trying to buy some stuff, probably, we'll have to see what's being passed to this function, of course, is less than the ambassador quota, which we define to be 20, right? That's what this is set to. The ambassador quota is set to 20 ether and can never change. It's a constant. In fact, what I'm going to do is I'm going to copy this. I'm going to copy these public variables here, and I'm going to paste them into a notepad so that way we can have quick access to them. I don't want to keep jumping back up to these variables here. All right, there we go. I copied these over. So let's go ahead and continue on through the code. If the total Ethereum balance minus the amount of Ethereum is less than or equal to 20, then we can go through here. So basically, the way I'm interpreting this if statement is that the ambassador mode has to be enabled, which it's not enabled anymore. Only ambassador is set to false right now, and we need to see if they have the ability to actually set this to true. Let's find that out. Here we set ambassadors equal to false. Here is where only ambassador is set to true. This is an initialization. This is only executed once the contract is put on the Ethereum blockchain and never executed again. Here's where we actually test the value. Here's where we can set it to false and only administrator can set it to false. And we're right back to where we started. So once only ambassadors is set to false, it can never be set back to true. Okay, unless somebody copies a contract and puts it into puts it on the blockchain at a different address. But this particular contract right here, so basically we're just taking the total Ethereum balance, we're subtracting the amount of Ethereum that's being bought, and it has to be less than or equal to 20, and then we can execute this code. So basically, in ambassadors mode, we can't exceed 21 tokens and then if we do exceed 21 tokens, then only ambassadors get set to false, and it will never ever be set to true again. Okay, so and then it executes the code there. Now let's talk about what if this is true. So what if we are in ambassador mode and we satisfy this requirement too? Well, the function is going to require that the ambassador, that the person who's transacting right now is an ambassador. Okay, and we're going to see who ambassadors are here in a little bit. So they have to be an ambassador, and the ambassador's accumulated quota, right, that the customer address plus the amount that they're buying has to be less than the max purchase, which is 1, right? We have that value over here. The ambassador max purchase is only 1 ether, so they can only buy 1 ether during this only ambassador stage. The next line here, so once this is satisfied, then we're able to continue. Otherwise, the transaction is null and it doesn't get executed. The ambassador accumulated quota is the customer address, and we're basically just going to add. By the way, we got to define what add is later on. We'll get to that down at the bottom. So we're going to add the ambassador accumulated quota of that customer and the amount of Ethereum that they're putting into the contract. So that's their accumulated quota. It's basically just adding. It's just really just adding the amount of Ethereum to the current value. Okay, to make sure that we keep track of how much this ambassador is purchasing. Then we can execute the function. And that is the end of the anti-early whale. And so basically what I've concluded here is that if the contract is in only ambassadors mode, then ambassadors have the capability to buy up to 1 ether worth of P3D. We will be in only ambassadors mode until the amount of Ethereum in the contract reaches 21. Okay. Now you're wondering how I get the number 21. Well, if the amount of Ethereum that we're able to purchase is only 1, then this value can be 1, right? Well, total Ethereum balance, if it's 21 and you subtract 1 from that, you get 20, which is less than or equal to the ambassador quota. Once we exceed 21 Ethereum, then we go into public mode. Anybody can transact on this thing. So this is really just a catch-all during the early stages to prevent some big whale coming in and just blowing up and buying a crap load of P3D. And we'll see why they did that also when we get into the math portion of this stuff in a later video. All right, so that's the end of that function. So anti-early whale, I have to admit, it is legit. I haven't found anything that's given the ambassadors anything other than the capability to buy in early. That's it. And it also limits their purchasing power. It also limits them on how much they can buy. Okay, so we have now line 104 and down, we have events. Basically, these just write extra information to the blockchain and also allow interfaces and applications to know when something happens on this contract. So really nothing special there. There's not a whole lot of room for exploit on these events. And then we already copied all of this data over into the text, so we have it readily available there. All right, now we get into some of the good stuff. Now functions. So now let's talk about what some of these functions are. So function hourglass. Now we already defined an hourglass to be a contract, and so we're also defining a function hourglass. Well, what this is called a constructor for you programmers. This code is only executed once and once only and never again. Okay, when the contract gets put on the blockchain, this will get executed, and now we got to see what happens when that happens. So we're adding an administrator. Whatever address hashes to this value is being set to is an administrator. Right, we already saw what only administrators have the capability of, so whatever address hashes to that is an administrator. Add the ambassadors here. So we basically just got a couple comments here to let us know who these ambassadors are, and we have their public wallet keys. So we know we can actually inspect what these guys are doing. I have their addresses, which is very transparent of them. That's very transparent. That's a good sign, guys. That's actually a really good sign. They're putting themselves out there to say, hey, we are these people. This is our signature. So all of these people are ambassadors. We'll see if there's any other special capabilities that these ambassadors have, though. There we go. Honestly, this is the end of the function. The only thing that's being executed when this contract, was put on to the blockchain, we're setting some of the global variables that we have copied over here in the text. Okay, and we're assigning administrators and ambassadors. That's it. There's nothing else special going on here. All right, function buy. So now we're getting into some of the really good stuff. We're going to see what's capable and what's not, okay? So the buy function is accepting a referral address. Of course, they have a referral program, right? So owning a masternode gives you a unique link to your website the smart contract recognizes. Anyone buying into the contract via your link has a 33% of all fees they would otherwise pay into the contract directed to you instead as instant Ethereum gains. We know that the dividend fee is 10%, right? So whenever you buy in or sell out, you pay 10%. So the 10% is actually hard-coded. It can never be changed, the dividend fee. We'll have to see how this is used later on in order to verify that. But we also need to, I don't see anything in here that shows that a referral has 33%, so we also have to find that in the code somewhere. Public, payable. So public, it's payable. What that means is that what payable means is that I'm able to actually send Ether to this function, okay? Which is good because I need to be able to, if I'm going to buy some P3D, I need to have Ether, right? So message.value, what that is it's the transaction value. Let's see if we can find here we go. Here's a buy transaction. So that would be 0.06 Ether or a really large number of Wei. So this is what MSG.value will evaluate to, whatever is set to the value of this. Okay, and it also passes the referred by, so the address that of your referral is sent to the purchase tokens. And we'll have to see exactly how these are used inside of this function. And that's all this function does, is just passes information to this function. So let's see what this function does. Okay, so it's taking in the incoming Ethereum and also the referral address. It's making sure, well, this is good. They're making sure that early on, you can't just buy a lot of tokens, okay? One thing I do need to stress about the anti-early whale modifier is that once the only ambassador's flag is set to false, this modifier no longer affects the function. So if for whatever reason, people sell down to about 20 Ethereum, or even if it goes to zero, even if the Ethereum goes to zero, then somebody's able to buy in and whale the crap out of this. So if somebody comes in with 10,000 Ether, for example, they can do that and they'll get a crap load of P3D. So that is a vulnerability thing. Okay, so purchase tokens. It looks like we're just setting up some data. Okay, we gotta set some data. We take the customer address. Undivided dividends is the division of the incoming Ethereum by the dividend fee. Now the dividend fee is 10. So we're taking the amount of incoming Ethereum and we're dividing it by 10, essentially taking 10% and putting it into the undivided dividends. The referral bonus is the division of the undivided dividends by 3. So yes, the referral bonus, there it is, right there. That is the validation for this line on the website, that you get 33% of all fees. Now, that honestly is just the fact that 33% is taken out of the dividends. How it's used is, of course, important. So we need to make sure that in the code it's actually used that way. But this is validation to show that 33% is, in fact, being stored in a referral bonus. The dividends is equal to the undivided dividends minus the referral bonus. So they're subtracting the 33% for the referral, and the rest of the people are going to get the 66% that remains. Taxed Ethereum is the subtraction of the income Ethereum by the undivided dividends. So what we're doing is we're making sure that we know the amount of Ethereum that's not being divided out, and that this is what's actually going into the purchase of P3D tokens. We have to make sure that that's how the code is actually written, of course. The amount of tokens is equal to the Ethereum to tokens function of the taxed Ethereum. So we need to define this function. Let's go do that real quick. Here it is, Ethereum to tokens. It is a positive integer of Ethereum. It is internal. What that means is that nobody can send a transaction to the blockchain to execute this code. It's not possible. And the code is view, so it's read only, and it returns a positive integer. This is really just a scale factor, and honestly, I want to save this function for the math portion of this, because there's just a lot of math going on in here. There's really nothing special. They're not setting anything. This is a view function, so we're really just we're just doing some calculations here, okay? So there's nothing really interesting going on in here except for just some math, and I'm going to cover the math portion of this in a later video, like I've said. Coming back up to the purchase tokens function, the amount of tokens that you're going to be, so basically this is essentially determining how many P3D tokens are going to come into existence when you buy tokens. They haven't came into existence yet because we haven't increased the total supply, but we're just getting that value real quick. And then we have a fee, dividends times the magnitude. There's that magnitude right there and the dividends. Let's move on down here. Okay, no point in continuing execution if OP prevents overflow in the case that the pyramid somehow magically starts being used by everyone in the world or hackers. And yes, we know that the safe math function. So they're basically requiring. Now, remember, whatever's inside of the require, by the way, require is a Solidity code. It is interpreted by the compiler. It's not actually written anywhere in this code. But this has to be true in order for the rest of the function to execute. So this could be a stopping point. And it's based on the stopping point if the amount of tokens is 0 or smaller. And basically, we're adding the amount of tokens to the total supply to make sure that it's greater than the total supply. So that seems kind of intuitive. Like, of course, if I add tokens to the token supply, why wouldn't it be greater? Especially if I add a positive amount of tokens. Why would this not be positive? And if, of course, programmers probably know this, but for you people that don't necessarily get that, there's a potential for overflow here. And whenever you get to the largest possible value that can be stored on a computer, what happens is it rolls over and it goes back to 0. So it's just making sure that that's not happening. If it does happen, cut the cord. This right here tells me that they are looking out, obviously, for hackers. So yes, what they say here in this comment is accurate. They're preventing any type of overflow. So good job on the due diligence there. So essentially what they're saying is this. First of all, do you have a referral? Is that referral not you? Does that referral also meet the staking requirements? If so, then the referral balance for whoever refers you is incremented by the current referred balance and by the referral bonus. We're just incrementing by the referral bonus. That's all we're doing is we're taking this value and we're incrementing it by this. If you notice that this right here, this whole thing that I have highlighted is the same as what my cursor is running over right now. Otherwise, if this wasn't a referral, if any of these conditions are not satisfied, then we take the dividends. Okay, we're gonna basically put the referral bonus back into the dividends, and then we're gonna recalculate the fee. Because what we did up here is when we calculated the fee here, we took the dividends that was based off of the referral bonus, right? So this dividends was based on the referral bonus, right? And so then therefore the fee is also dependent on that. And what we got to do is once we put the dividends back, the referral bonus back into the dividends, we have to recalculate this fee. We can't give people infinite ether. So token supply is greater than 0. So if the token supply is greater than 0, then execute this code. Let's assume that the token supply is 0. What happens? Well, simply the token supply is going to equal the amount of tokens being bought. So honestly, this should only be executed once at the very beginning, unless for whatever reason the token value, the amount of Ethereum in the contract goes to 0. Then this will be executed again. But if the token supply is greater than 0, then we got to do some more math here. We got to basically increase the token supply, and then they're calculating the profit per share. It's the profit per share is equal to the dividends times this magnitude and divided by the token supply. Okay, so here we go, the token supply and then profit share. Now, this is important, guys. This is very important. Okay, the order in which this is executed is pretty interesting, okay? The token supply is increased before the profits are divided out. You understand that? The token supply, so whenever you buy tokens, those tokens are included before they actually pay out the dividends. Okay, so let's say I have 100 P3D, you have 100 P3D, okay? We have an equal share, right? Well, if I buy 50, then the total supply is increased to 250, right? And then the profit per share is divided out. So the supply increases before the divisions. It's very important. You got to understand that happens. That's what's going on in this code here. Okay, and then here's some math to calculate the amount of tokens the customer receives over his purchase. But there's nothing very special here. Honestly, when we get to the math portion, we'll see a little bit more about what this means. The token balance ledger at the customer address, so whoever's buying tokens, your balance ledger is going to be set to your current token value plus the amount of tokens that you're gaining. Tells the contract that the buyer doesn't deserve dividends for the tokens before they are owned them. Really, I know you think you do, but you don't. So the updated payouts is equal to to an integer, so it's a positive or negative value here of the profit per share times the amount of tokens minus the fee. So there's their fee being used. We said it a few times, but here it is being used. It's also used here to calculate the fee. We'll see more about that in the math portion. Payouts to the customers equal the payout, so updated payouts. Okay, nothing really too special going on in here, guys. This math looks like it's working out. We'll get into more of that when we get into the math portion, and then the next thing to do is to fire this event, so that way, any applications like the exchange knows when somebody has bought tokens, and it gives a bunch of information about what address bought them, how much Ethereum came in, how many tokens they got, and if they were referred. Okay, and then this function is going to return some new tokens. Okay, now it's also worth pointing out that this right here, this piece of code here and this piece of code here is kind of a magical thing, because this is increasing the supply of tokens. Straight up, this is what is creating tokens and bringing tokens into existence. It's not something magic, but this is just numbers in a system really that create these tokens. It's like your bank account. And that was the purchase tokens function. As long as the variables in here are used as we believe them to be intended, then I would say that this function checks out. Nothing special going on here. Nobody can buy any extra tokens. Everybody's on the same playing field when they buy tokens through this function and also through this function right here. Okay, so that is the buy function, and I've concluded that there's nothing incredible going on here. We're really basically buying tokens, doing some math to figure out how many tokens you get, how much profit people get, how much dividends people are going to get, that sort of thing. It's also worth pointing out that this line of code right here is also sort of magical. This is basically a factor to determine how much Ethereum your holdings are worth. So that's also kind of a really awesome thing to kind of see here in the code. That's basically where that's all coming from. And with that, then we're going to finish up the buy function, and we are going to move on to the next one. All right, fallback function to handle Ethereum that was sent straight to the contract. Unfortunately, we cannot use a referral address this way. What this is called a fallback function. And if I don't call the buy function, if I call no function at all, then I can just send Ethereum to the contract, and that address that sent to Ethereum is going to get some P3D tokens, because we call that purchase tokens value, which we just covered. I don't need to cover it again. We understand what that does, and we need to understand that what it does from here on out. All we do is we send the value of the ether that was sent and no referral. All right, some more good meat. Oh man, some reinvest function, reinvest. Here we go. Only strong hands are able to reinvest. And if you recall, in order to have strong hands, you have to have dividends, okay? If you don't have dividends, what are you going to reinvest with? Okay, so let's see what goes on here. So dividends is equal to my dividends false. In this case, we do not want to know, we do not want to consider how much referral bonus you have. And it says here that the retrieval of referral bonus is later in the code. So they tell you straight up, hey, we're not going to get the referral bonus right now. We'll get it later in the code. We'll see if that's true, of course. Pay out the dividends virtually. So we'll just take the customer address. Once again, we've seen this line of code a couple times already. Payouts to the customer address is going to be basically just incremented by the dividends times the magnitude. Retrieve the referral bonus. So here is where they finally retrieve the referral bonus. They wanted to actually increase your the amount that you've been paid out to without considering the referral bonus, and then they take the referral bonus here, and then the referral balance of the customer is set to 0. And that makes sense. You're reinvesting everything, right? So reinvest, it doesn't accept any values into it. This is an all or nothing function. Okay, let's continue through this real quick, and then we'll get back to that. UNT tokens is going to equal purchase tokens. Here we go once again. Okay, the dividends. Okay, and no referral. So whenever you reinvest, whoever referred you does not get a cut. So your reinvestments are spread throughout the entire community, and not your referral does not get any benefit of that. That is spoken right here in the code. So the code is telling me that whenever you reinvest, even if you were referred to the platform by somebody through a masternode link, that masternode link does not get a cut of that referral bonus by 33%. He gets the same amount as everybody else. And then they just fire an event on the reinvestment. There's really nothing going on here when they fire the event. We're just informing other platforms and writing to the blockchain that this happened. So nothing special there. And we send the customer address, who's buying the tokens. How much are they reinvesting? The number of tokens that they're getting. Okay, so remember that whenever you purchase, given the dividends, right? The dividends, so essentially the dividends that you have are sent to purchase tokens. It's divided up and then divided out to everybody else, and then you get an amount of tokens for whatever's left. And then we fire this event. And that is the end of the reinvest function. There's really nothing special here. It's super straightforward right there. A couple good points in here, though, is especially the fact that your referral does not get a cut. So yeah, nothing funny going on in here. This code makes sense to me. I think that is a straight up reinvestment code. Okay, so now function exit line 298. This is an alias of sell and withdraw. All right. So they have a couple of functions here, withdraw, and also one here that's sell. So we have 3 different functions apparently that do the same thing. Let's see what the difference is between them, because they don't look like they're the same to me. Like I said, it all depends on what the code says though. This is public, so anybody can send a transaction to this function. Get the token count for the caller, sell them all. All right, so address, customer address, the token balance ledger, however many tokens that this customer has is set into this variable. Okay, so however many tokens that person has, if it's greater than 0, then we'll sell them all. And then we will withdraw. So basically, this exit function is telling me that we're gonna sell all your tokens back to the system, and we'll see what that actually does here, because we got those functions coming out. And then we're gonna withdraw that to your MetaMask account, most likely, if the address that you're using is on MetaMask. By the way, you don't have to use MetaMask. That's just how their exchange works. This is a smart contract. Anybody can interface with this however they want to. If you have Ether in any Ethereum address, you can interface with this contract. It doesn't matter. So it is legitimately a decentralized exchange, just like they said right here on their website. It is a decentralized exchange because it is a smart contract on the Ethereum blockchain. They provided us with this exchange. Anybody can write an exchange to interface with this smart contract. That is just how it is. So yes, this is true. Let's talk about the withdraw function. That's coming up next, and then we'll talk about the sell function. But that's pretty much what the exit function does. The exit is basically it is an exit. You're exiting, you're selling them all, and you're withdrawing, you're leaving, you're gone. Okay, so let's see what this withdraw function does. So only strong hands has the capability to withdraw. Anybody that has dividends is considered to have a strong hand. All right, so withdraw, only strong hands, and anybody can execute this function. We take the customer address, once again, there's that line of codes, and we find the dividends and we store it into this variable. Understand that the dividends is being added to your payouts. Add the referral bonus to the dividends. Okay, so we're just not taking the dividend, right? We're not taking the referral yet, so that we can calculate this payouts too without the referral bonus included. And then we take the dividends and we add in the referral balance for that customer address. So the referral, and then it's set to 0 straight up. And then we do customer address.transfer the dividends. We're transferring their dividends to that customer. So whatever address you have in Ether. So we're actually sending Ether back to your address. This right here is proof that the payout is real. Okay, at least on a withdrawal of your dividends. That's just all there is to it. Okay, now we have to see if the sell actually sells your tokens correctly and then gives you Ether back and puts them into your wallet so you can withdraw them. On withdrawal, customer address, dividends. So yeah, this function right here, very, very major to discuss that, you can leave. you can leave whenever you want. You can take your money, your Ether out at any time. And this function, this call right here tells me that you get your Ether back, at least what you have in your dividend wallet. Now, it remains to be seen if you're able to convert your P3D back into Ether and take that out. But as far as dividends are concerned, you can take your dividends out. 100% positive on that. So once again, the withdrawal function, there it is. I have no problems with it. This definitely does what they say it's going to do. So on their website, they claim that you can withdraw anytime. The smart contract, your new RoboBlah, holds all Ethereum ever put into purchasing tokens and will gleefully give you all Ethereum you are owed whenever you want to withdraw or dump your tokens, you weak-handed fool. I love the satire on this. I love this stuff. The robot is also indifferent to the plight of man, cannot be stopped, shut down, or ended without the death of Ethereum, blah, blah, blah. So yeah, I would say that at least we have came to the conclusion that you can withdraw your dividends at any time you want. Like I said, it remains to be seen if you're able to cash out your P3D into Ethereum and withdraw it. Okay, that still remains to be seen. So I also want to, while I'm here, I want to comment on this. The robot is also indifferent to the plight of man, cannot be stopped, shut down, or ended without the death of the Ethereum network itself. Is 100% true. Nobody can shut this down. This is a smart contract on the Ethereum blockchain. Okay, and all the information is stored there. Nothing is stored on the proof of weak hands exchange. Nothing is stored here, guys. This is all just front-end work to get access to the smart contract. And like I said, anybody can make an exchange to interact with this smart contract. Okay, so moving on, sell. Now this should show us that you can actually cash your P3D out into Ethereum. So that's what this sell function is going to hopefully show us. Only bag holders are allowed to call this function publicly. Only bag holders are people who have tokens. So if you have a token balance in your Ethereum address, then you can call this function. You can sell your tokens. All right, let's do the dirty work here now, guys, for the sell function. This is going to tell us everything here. All right, address is okay. We've seen that several times. We're just getting a description of the customer address. We require that the amount of tokens that you're transferring is less than or equal to your total balance. Okay, so you can sell any particular amount of tokens you want. Okay, but it has to be less than or equal to your current balance of tokens. That's just, if this evaluates the false, end of function, transaction doesn't complete, you still pay the gas. So the tokens is going to equal the amount of tokens. This is kind of redundant because we have this. They're really just kind of shortening the name, it looks like, to try to keep the lines of code low. The Ethereum is tokens to Ethereum. We still have to define that, and we're going to do that after we get through this function. Let's assume that it does what it says it does for now, and then we'll come back to it. How much your Ethereum, your P3D is worth. The dividends is going to equal to that Ethereum divided by the dividend fee. Once again, this is now 10% of what you want to take out. The tax Ethereum is equal to the Ethereum that you want to take out minus the dividends. Okay, so this is what remains after the dividends are divided out. Burn the sold tokens. So the total supply is equal to the total supply minus the tokens that are being removed. So this is an extremely important line of code right here. This is telling me that the number of tokens that you're selling, the total supply is reduced by that amount. When you sell your tokens, the P3D that you have go out of existence. They no longer exist. Token balance ledger is equal to the customer. Token balance ledger of the customer who's selling the tokens is equal to the subtraction of their current balance minus the tokens. Okay, so basically you no longer have those tokens. However many you sell, you no longer have them. Update payouts, once again, some more math. It's just the profit per share times the number of tokens. So how much profit you gained plus the tax Ethereum times the magnitude. Once again, we'll get into the math portion of all this in another video. Nothing special going on. It's just some math. Okay, no administrators get anything special. No ambassadors are getting anything special. So we're updating the profits per share. Once again, we'll be going through the math portion of all this to make sure that this is accurate, but currently nothing special in here. This seems to make sense. Okay, guys, so I think we just covered 3 of the most important functions, the exit, the withdrawal, and the sell functions, and concluded that Everything is legit here. There's nobody special here. You don't see ambassadors mentioned here. You don't see administrators mentioned here. All you see is some math that try to keep track of how many dividends you have, what's your referral bonus, how much has been paid out to you, how much P3D do you have, what's that P3D worth, that sort of thing. That's all that's really being tracked in here. So, so far, this is looking pretty damn legit to me, and I'd like to see somebody try to refute this without reading the code, because honestly, if you just say, well, it's fake, they're gonna exit scam, well, not according to the code, they cannot do that. It remains to be seen, though. We're not done with the code. Let's go through this. All right, transfer. So transfer tokens from the caller to a new holder. Remember, there's a 10% fee here as well. So we're accepting an address to where do we want to send the tokens to? How many tokens do we want to send? Only bag holders are allowed to call this transfer function. Obviously, if you don't have any P3D, you can't send it. It is a public function and it returns a bool. Once again, we've seen this line of code, just copying the address into this variable. We require that, first of all, we cannot be in ambassador's mode. And the amount of tokens that's to be sent has to be less than how much you have in your ledger. Okay, so those two are required in order for to continue execution of this code. Otherwise, the transaction fails, you still pay the gas. Okay, so my dividends, considering the referral bonus, has to be greater than 0, and then we will withdraw. So what this is telling me that when you transfer, they are forcing you to withdraw your dividends first to your MetaMask or whatever address you have. So you actually take out your dividends. Okay, so whenever you transfer, don't be surprised if your dividends go to 0 because they were sent to your MetaMask account. So check there. That's where you're going to find your Ethereum. Liquefy 10% of the tokens that were transferred. These are dispersed to shareholders. So the token fee is the amount of tokens you want to take out divided by the fee. So 10% of the amount of tokens you're taking out is done here. The amount of tokens minus the token fee. So how many tokens are you taking out? What's the fee, which is 10% of that? We're just subtracting 10%. And this is the remaining value. So the 90% is what's put in here. And then the dividends is equal to the tokens to Ethereum of the token fee. So then we store that in the dividends. The token supply is then reduced by the token fee. So this is another destruction of P3D tokens. So we're destroying some more, and it's basically just the token fee. So it's the 10% that's coming out. Token balance ledger is so we basically update how much you have, how much you're holding, okay, and we're just subtracting off that amount of tokens, the total amount. And then token balance ledger, the to address, who are we sending P3D to? That's who we're going to be adding their token balance ledger by the taxed tokens. So you get deduced by the total amount of tokens that are being transacted, and the person who receives only the 90% that remain. Update the dividend trackers. So once again, some math here. Basically, the payouts that were paid out to you gets adjusted based on the amount of tokens that are being sent out. The payouts to the address get incremented by the taxed amount. So nothing really special here. Let's move on. Profit per share. We're just basically updating the profits per share based on the new token supply, because remember, we actually deduced the token supply, and now we're determining how much profit per share exists in the ecosystem. We transfer. This is an event, a transfer event. So we're just pretty much telling apps, hey, there's a transfer that took place, and this is the information. This is who sent it. This is who it went to, and that's how much was sent to them. We don't get any information about how much was actually taken out of the account, but you can do the math here. You just divide this by 0.9 and you have the total amount. So the conclusion here on the transfer address, on the transfer function, is nobody else can do anything special except you have to have tokens, obviously, to transfer. Ambassadors, administrators have no extra rights in this function. So it is, to me, 100% legit. Of course, the math still needs to be made out to make sure that nothing else is going on. Like I said, we'll cover the math portion in a different video. If I did the math in this video, this would be so long. Okay, so now we've gotten through all the functions. We're down into what the administrators can do. So only administrator, we already talked about this. They have the ability to set only ambassador mode defaults. They have the ability to add an administrator. They have the ability to change the staking requirement. They have the ability to change the name from a proof of weak hands 3D to something else. And they have the ability to change the symbol from P3D to something else. That's all this is. And then we go down into some helper functions. Total Ethereum. Once again, we've already seen this function. We just return the current balance of the smart contract. The total supply, if we want to know. I don't think this was actually called anywhere inside of this smart contract. It's there as a read function for everything else. See, there's no other instance of this in the smart contract, but it's a way of interfacing and being able to see some stuff. Nothing special there. You just return the total token supply. It's read only as well, but anybody can call it. Okay, so my tokens, basically you're going to have to transact, right? So they can know what your address is based on the transaction. You send it to there. It is a read-only function, and it's going to return a positive integer. Once again, that, and then the balance of the customer address. Again, we've already covered these functions, so there's no need to do it again. My dividends, I covered this one already. Balance of, we covered that. Dividends of, we covered that as well. And then, okay, so here's a couple of really good things to talk about here. So sell price. This is also not used anywhere in the smart contract. Okay, this is the only instance of it. And also buy price right here. We'll talk about these functions here in a second. I'm just going to try to see if they're used. They're not used anywhere in the code. So this is all just information that is accessible through the contract. These are view functions. They don't modify any of the data. They just read data and send out information. If token supply is equal to 0, so if the token supply is 0, then the token price initial minus the token price incremental. The initial token price, you subtract off the incremental token price. That's going to be a decimal with 8 zeros followed by a 9. That's the initial token price. The Ethereum, so we consider the tokens to Ethereum. Oh, by the way, we still got to go through that function. I totally forgot about that. Okay, here we go. This is the tokens to Ethereum function that we needed to talk about. It is an internal function, so only functions inside the contract are able to call this. It's not publicly available, and it's read only. It's not gonna modify any of the data, and it returns a positive integer. So the uint, the tokens, is the tokens plus basically just a scale factor. Once again, this looks like just math. What I'm really looking for here is any potential for the administrators or anybody special, have a special address, have any special functions. It's basically just gonna do some math, and like I said, we're gonna talk about the math portion of this later. We definitely want to crunch this function and this function, Ethereum to tokens, so the reverse, to make sure that they match up. They should be inverses of one another, right? So we will definitely be doing that in a later video. Okay, so the sell price, if the token supply is actually greater than 0, is going to be, so the Ethereum here is actually, tokens to Ethereum, we're sending a constant value to this, and it's just one P3D token. How much is one P3D token worth in Ethereum is what we want to know. And we want to know also how much dividends would be taken from that, and how much Ethereum is left over when that is done. So that's all that's going through here in this math. And then we return the tax Ethereum. That's all that there is. So now we know what the buy price is, because what they're doing is they're creating a split. When you buy, right, you gotta buy at a certain value, right? But you also are going to spend 10% of those dividends. So this function determines how much the effective value of those P3D tokens. So this makes sense. Nothing special going on here. Let's move down to the buy price. So anybody can call this. It's read only, and it returns a positive integer. If the token supply is equal to 0, then the buy price is equal to 0.6 zeros and a 1. That's what the value is at the very beginning when the token supply is 0. How much is one Ethereum worth in tokens is what we're going to find out here. Okay, we've already went through these functions. The dividends is equal to the division of the Ethereum by the dividend fee. So now we take that off. We take the tax Ethereum is the addition of that Ethereum with the dividends. And now we know how much what the buy price is. Okay, so all of this makes sense. Nothing funky going on in here either. Okay, so here we go. Calculate tokens received. This is a function for front end to dynamically retrieve the price scaling of the buy orders. Nothing interesting going on in here. We take an amount of Ethereum to spend, and it will spit out a number of tokens that you'll get if you decide to buy. Okay, so we take the dividends, we divide off the divisor. The tax Ethereum is the subtraction of that, of the total amount of Ethereum, and the amount of tokens remaining, and then we convert that into tokens to determine how much tokens you would get depending on how much Ether you spent. And the dividends are also taken out of that, so we know exactly how many tokens you'd get if you bought. So nothing funky in there. It works fine. Let's go to calculate Ethereum received. If we're going to sell some tokens, we want to know how much Ethereum we're going to get. So this is public. It's read-only, returns a positive non-integer. It requires that the tokens to sell is less than or equal to the token supply. If you're going to try to sell more tokens than the supply, then obviously there's something wrong there. And so that has to be satisfied in order for the function to continue. So then we convert the amount of tokens you want to sell into Ethereum. We take out the dividends, or we calculate how much dividends is going to be coming out of that. And we determine how much Ethereum is left over after the dividends is taken place, and then we return that amount. Nothing special going on there. This function makes sense. Moving on, we come to the internal functions. We've already talked about purchasing tokens. Okay, so this function can be closed. Calculate the token price based on the amount of incoming Ethereum. So we've already talked about this one. We kind of glanced over it because it's math, and we want to talk about math later. Okay. Tokens to Ethereum. Once again, we talked about this one. It's math. We'll talk about that in the math video. And the square root function. So apparently there is currently there's no standard way of calculating the square root function in Solidity. You have to kind of make your own square root function, and that's all this is. And it's very, it's very process intensive, which is why your gas prices are so high, because we got to calculate the square root of stuff. And then, my friends, that is the end of the contract. Here's the closing squirrely bracket for Hourglass. Okay, so once Hourglass is closed, there's no other functions that can be called on this contract. We do, however, have a library down here. We're gonna quickly glance through this, see if there's anything funky. But once again, this is math. Okay, so this is library of safe math. We have a multiply. All right, we take two numbers and we're going to multiply them together. And you may be wondering, why don't you just use the star function? Or why don't you just do this outside of this? Well, because we want to make sure that there's no overflows going on. This is what's preventing hacking from occurring on the proof of weak hands thing. Now, I'm not going to say that it's completely hack proof, okay? There may be some nuance in here that may be exploited, but this is preventing a lot of hacks from occurring. Okay, so this is their due diligence on the developer's part to ensure that your tokens are safe. That's all that's doing. We got a function to divide. Once again, it looks like they just divide it and then they send it back. So there's no case in which this doesn't hold, but they kind of have it there just to show that it's safe. All right, we have a subtraction. Okay, now we just got to make sure that B is less than A, and then we subtract A from B. This is just to make sure that, once again, no overflows. Okay, and then add. And by the way, this is the end of the entire contract, by the way. But we also have an add function, and we make sure once we do the add, we just make sure that the add didn't overflow, and then we return the right value. So nothing special there. These are just simple math functions, and they're also safe. They're hacker safe. That's why they're in a library called Safe Math. One thing to notice is that these functions are also pure, and what that means is similar to view, where it's read-only. Pure means it's not able to read. Not even able to read any of the data in the contract. So it is a pure function. It cannot read or write in the contract. It's really just taking two numbers, performing an operation, and returning a value. So that's what this pure means. So with that, we have covered everything in this contract. I see no reason to suspect that there is any way for any of the developers to exit scam. They don't have very many special abilities, administrators or ambassadors. Ambassadors, they have no extra ability. They're just able to come in early. Up to 21 Ether can be spent, and then everybody's able to enter the contract. Administrators do have a little extra rights. They have the ability to change the name in the P3D. They can also add administrators. I want to point that out because it's not mentioned anywhere in the comments. So, once you're an administrator, you can add another. You can start adding people as administrators. It's very important that that's actually known. Of course, an administrator can't do much other than change a few non-essential things in order for the contract to stay alive. So, assuming that this is not a hackable contract, I am inclined to conclude that this is absolutely 100% legit, and everything that they say on here is in fact true. There is nothing in here that is false, including the fact that this is a pyramid scheme. Legitimately, it is a pyramid scheme where investors are supported by future investors. But honestly, you could say the same thing about Bitcoin. If I want to sell Bitcoin, I got to sell to somebody who's willing to buy, right? So I'm actually being supported by that buyer when I sell Bitcoin. Right here, they talk about for each token added or removed from circulation, the price of the next token increases or decreases automatically by a fractional amount of ETH, about this much ETH, which is 1, 2, 3, 4, 5, 6 ETH. So, and it changes. It depends on how much is being bought at the time. But that's also true. when people buy your tokens are worth slightly more. That's also true, which we'll see in the math portion of stuff. So there's nothing in here that's false. Nothing. I can't find a single thing in here that's false, including the fact that this is a pyramid scheme. So I think Proof of Weak Hands 3D kind of shoots itself in the foot by saying, hey, you know what? We are a pyramid scheme. Guess what? That's awesome. Another thing to point out is that Proof of Weak Hands 3D is backed by the Ethereum in the contract. So it does, in fact, have intrinsic value in that end. Now, of course, we can question whether or not Ethereum has intrinsic value, but the fact of the matter is that Proof of Weak Hands does have intrinsic value in the Ethereum that is stored in the contract. So that is also a false statement when people try to claim that it's not backed by anything. It is backed by the Ethereum in the blockchain, according to the code. Nobody can refute this. The code is the law, and nobody can modify the code. So I think I rest my case on this until we actually look at the math. Can we actually say some things about what's actually going on with the value of things? That all remains to be seen. But I am convinced, going through the code, I challenge anybody to look through the code themselves or try to prove me wrong on any of the points that I've made in this video, and we will come to a conclusion. Leave your comments down below. Anyway, thanks a lot for watching. That is the conclusion I have. Proof of Weak Hands 3D is absolutely legit. Everything they say on the website is 100% true. Their exchange is in fact decentralized. There is no reason to believe that they can exit scam. They can't. It's not in the code, and that's that. So anybody who claims anything to the contrary is simply just trying to spread FUD. This is the Crypt, and thank you very much for watching. I'll see you guys in the next video. Take it easy.